First we go and search on the term NIST statistical reference datasets, and it'll lead us to this website. So just go in and click here. Remember, National Institutes of Standard Technology, NIST statistical reference datasets. Click there and we go into the statistical reference dataset. As it said, there's a lot of information, but these are reference datasets for doing exactly what we're going to do, and is test our curve fitting abilities. We're going to go to dataset archives. We'll go straight down to nonlinear regression. Since your assignment deals with Gauss1, I'm going to do Gauss3, which apparently is a harder curve to fit than Gauss1 or Gauss2. It contains 250 data points, same amount as here, and it has 8 unknowns to be solved for. But before we do that, let's go in and take a look at what Gauss3 looks like. And this is the data set and how the curve should be fit. So if we take a look at all of the information, what we see is first our curve, and what we see in here is an entirely large set, in fact 250 data points that are clustered all along in here. Our goal, of course, is to find a function that fits this data set, and if you observe this really closely, what you'll find is that yes, in fact, this data set is fit well with the curve that you see right here. So if we take a look at this curve, he wants us to fit a function y as a function of x that looks like this term. Now this epsilon here is just simply the error, so it's not included in our terms, but we see a complicated term. We have beta 1 e to the minus beta 2x plus beta 3 times e to this amount, which is up here, minus x minus beta 4 squared over beta 5, and so on and so on. So you see these terms. You see that there's beta 1 all the way through beta 8, and this is what you see. So you see 8 parameters, 8 unknowns. If we can pick the right unknowns, then the curve will be just like you see right here. How do we do this? Well, this is where we're going to start looking at cost functions and regression and how this takes place. So let's take a look at this. All right. Let's say that we have a function just like this, where this is x and this is y. We'll zoom in on the plot that we had last time, and we'll see this is the curve to be fit, the function of x. In our case it was complicated, but it doesn't have to be complicated. So essentially what you saw was y is equal to some function of x. Now it turns out that our function also had function x, and depending on the notation, be beta 1 all the way through beta 8. But this is the x value, and these are our constants. Now, let's just take a simple case. Y is equal to ax plus b. Better yet, that could be written as y is equal to beta 1 x plus beta 2. So we have two unknowns here. Now, the key is, how do we find beta 1 and beta 2? Now, if that's the case, this is our function. We've decided to abandon this for the moment just to take a simpler case, and we throw some data points on it. Look at these data points, and you can see that this may be x1, y1, this may be x2, y2, and x3, y3. So how do we find what the best curve is? In our case, we're looking at a straight line. So what we're looking at is something that would look just like this. Is this the best straight line? Or is this the best straight line? Or how about this one? Or how about this one over here? Or this one here? Or this one right down here? How do we know which one's the best straight line? The key is to write it in a generic sense, or say this is our representation. Now what we're going to do is we're going to look at some terms. We're going to draw a line from here to here, from here to here, from here to here. We're looking at distances. So this is a distance 1, this is a distance 2, this is a distance 3. So what we have, so let's say we decided that we wanted to find this, and let's say we wanted to find out a way that D1 plus D2 plus D3, call that some cost function. However, the problem is that this one would become negative, this one would be positive, this one would be positive. So this doesn't work very well, so we need to square each term so that the negative numbers become positive. And what we're really looking to do is we're looking to minimize this cost function, say cost function C. But the C is a function of D1, D2, and D3, which are in turn a function of beta 1 and beta 2. So if I wrote this correctly, let me see if I can fit it in here, cost of beta 1 and beta 2. So all I need to do now is vary beta 1 and beta 2 here in order to make this term go to the minimum. Now what they do in a stats class is sum is equal to I is equal to 1 to 3 of di squared, which in fact, what is the distance? The distance is, we have to look at this real close. It doesn't matter whether, since it's squared, I can subtract this value from this value, or I can subtract this value from that. If I'm squaring it, it doesn't matter. This in fact becomes, you have to realize this is the location x1, this is the location y1, this is the location y as a function of x1, but it's not written that way. It's written as f. Remember, it's written that way right over here, which in fact is that term. So now we're subtracting the distance here. Y sub I, because we're looking at this one, but we can be easily looking at any of them, minus f of x sub I. And then squaring that, because that in fact is the distance. That being the case, I can now take my actual function and put in here. Now a stat in statistics, that's what they would do. They would go ahead and put that function in there, but you wouldn't need to. So in our case, we're not going to need to, but in stat, what they would do, beta 1 and beta 2 equals to sum I equal 1, 2, 3 of y sub I. Putting this in here and putting it down here becomes minus beta 1 x sub I minus beta 2 squared. Now you have to remember the minus was tacked on to both this terms, so that's why I got a minus here and a minus there. So let me reduce all the clutter here. Whoop. Okay. Alright, I don't know what happened there, but it apparently moved some terms here. Okay, so I was able to get them to move back. Okay, so that's the case in stats. What they would do is they'd go in now and they would say, well, I need to take the partial of c with respect to beta 1, set that equal to 0, and partial of c with respect to beta 2, set that equal to 0. However, this is for an easy equation. In our equation, it is not easy. This is our equation. It has exponents, e to the terms with betas in them, and anything that is nonlinear causes a trouble because you may not be able to take this differential. So let's abandon that idea for our nonlinear cases and let's stick to this concept. Not this one, but how about this one? We're going to take it back to our cost function, beta 1 all the way to beta 8 minus f, and what we're going to do is we're going to use this form. I'll basically remove that. X sub I beta 1 all the way to beta 8, and then I'm going to square it. Now there's no partials to be taken here, and instead of 3 data points I have 250. Now you're sitting here looking at what you have to do. You have to sum every single one of these. You have to insert the function here, evaluate it at that value, look at the data point, square it, and then that gives you your cost function. Now, what we actually end up doing is taking all 8 terms and changing them, moving them up and down in an intelligent manner, optimizing, basically making this go to a minimum by changing beta 1 through beta 8 in an intelligent manner. Now intelligent, there's a term of optimization in which you can start looking at it. There's things like conjugate gradient, steepest descent, all sorts of terms like here that can basically minimize a function by varying a set of values, and this c is a function of those values. So if you change beta 1, you should change c. This is exactly what we're looking at. So now that we know what we want to do, let's take a look at our data. Now here's the data file. If I click it, depends on, say I am in I'm not in Explorer, and I'm not on a computer on the campus. So what you see is Firefox will simply print out this file. Now this file is a DAT file, So if your computer has an association for the DAT, it will try to open it in that. If that is the case, what you can do is right click and save link as, and then put it somewhere. Say put it on your desktop or some particular file, and start working on it. Now it says it's a text file, so I'm going to assume that that's what you're going to do, and I'm going to save it there, and I'm going to work on that. So I'm just going to save it on the desktop for say. Okay, it is saved there. I can open. Hit open. Select. Make sure you select all files. Look at your term. Okay, you want it to be delimited. Go to next. Hit a space. Now it's going to put a delimited between each of these spaces. The only part you're going to concern yourself with is your data. Then hit next and hit finish. Now what happens is everywhere there was a space, it put it in a different column. So it looks complex. All your data is here, but what you see is these are your parts that you're mostly interested in. Now I'll get into all of these terms as well. Since I've imported everything exists in here. But here's your first part that you should pay close attention to. Your X data and your Y data. Now what he's done traditionally different in this data set is traditionally X is listed before Y. So what we're going to do is we're going to hold the shift key down and select all of that data. We're going to copy it. I'm going to move over to a new sheet and say right there, I'm going to paste it. Move back. Select this. Copy that. And then paste that. I'll just call this X. I'll call that one Y. Now what I can do is just simply select the entire data set. Now I'm in Excel 2007, so 2010 will be quite a bit different, but it still should be fine. I'm going to go and insert a scatter plot with just points. So as you can see, I don't like that series on there, so I'll select and delete it. But that's just the data points. Next I need to work on the data points, or the curve, I'm sorry. So what I'll do is come to the very top of the page. Now when I've done that, I've left this picture behind. So unfortunately I don't like that, so I'm going to drag it. And sometimes it works well, but I've drug it to the very top. There is the plot. So what I need is I need to make sure that I remember that I'm looking for my cost function, and there is a summation here. So if I'm back over here looking at this, I'm basically going to do this in a stepwise manner. Here's what I'm going to do. I'm going to evaluate the function, put it in a column. I'm going to take that column, subtract it from another column, and then square that. So this will be the square of, just call it the y's. So this will be in a column. I'll subtract these two. Then I'm going to sum all of those to get the cost function. Let's go and do that now. But first we have to represent our function. So in order to get that done, I'm going to go and basically make use of a typewriter. Okay, now first he's represented this as B1, B2, B3, B4, B5, 6, and 7, 8. So I'm going to rename this, or name my function. Just go out here to G, for example. Call that B1, B2, B3, B4, B5, B6, B7, and B8. I'll just put ones everywhere. Next thing I'm going to do is I'm going to put a name, create a name for that. Name a range. I'm just going to call that, looks okay to me, B1 with an underscore. Name a range. Whoops. Here. Name a range. B2 looks good to me. Name a range. B3. Now he's putting an underscore on there because there's already a B1, B2, B3. That's this value. So you see it got named. This one got named. You can see the name over here. This one got named. This one's not named. It's still listing as J2. So I'm going to name it. Sounds good. Name a range. Sounds good. Name a range. Sounds good. Name a range. B7. And name the last range, which is B8. Now, what I'm going to do is I'm going to put my function right here. Then I'm going to put my cost function right there, and then I'll leave these two for something else. Now, I need to fill in what my function is. If I go back to my spreadsheet, I could somewhat cheat. Hit a copy. Go back to here. Paste. Now what I've done is I've done this 2 asterisks is the same as a power. Power. Okay, now I'm not complete, but I'm going to hit enter. I'm also going to make sure I put an underscore on each one of the B's. B. Now my X is no longer an X, but I'm going to hit enter to store it. And next I need to go back and reference, instead of X, I need to put that value in. Whoop. Now I've got an issue here. Interesting, I get a backup, put an equal back on it. Whoops, that did not work. Now back up, take that space out of there, because if you put a space in there, it thinks it's a text. So now you see the blue references the blue. Here's what I mean by this. Well, when it got brought up, this color was the same as that color. We'll look at it again in a minute. This color got matched to the color of that box, and so on and so forth. Take a look at it again. And what you see is, yeah, this is blue, that's blue, green, this is green. So these color coded. Problem is I have no value of X, so he gets mad at me. So I select the X and I click that, and you see it filled in the A2 there. Go down here now and fill out this and click that. I believe you're okay. So at this point you have part of your function in. You don't have anything associated with B6, 7, and 8. That's because that was on the next line. So I'll copy that and then paste it right here. put an underscore here, underscore here. Now see, the problem is you'll see that this B7 is referencing the location B7 here. I want it to reference this B7, and here's this. Now I need to go ahead and put my caret for the squaring symbol and the caret here and hit an enter. Now it says I'm still in error somehow. Let's take a look, and we see our culprit right here, and we have our cost function. This is the function that was represented by going right into here. This is the function. This is the cost function. So you get all the clutter off here. Now, as we go through this, you can now copy this, and what you'll notice by selecting this, since I named these locations, it always references back to these. If you ever get caught in here and you want to get out, hit the escape key and you're back out to here. There is an issue here which we'll get to later, but for the moment we're going to just stick with this, and we're going to see some issues here shortly. First of all, we're going to ignore this momentarily, but it blows up for a reason which we're not going to talk about at this particular point. But just keep going, and now we're looking for the cost function. What was the cost function? The cost function simply was to take the value of y, subtract it from here, that becomes the distance, and then we square it. Now we're going to sum it, but right now we're looking for this distance. So that simply becomes equal to parentheses this one minus that one, and then we're going to square it. Now we just go on down, pull this to the very bottom, and initially we're okay, but what we need now is the total cost. And I guess I could move the column over a little bit and put it right here. This one will be equal to sum of every single term. Now we know this is going to blow up because we already have a number of issues, but just keep going, hit enter, go to the top, and you know it blew up, but that's okay. So the key here, when we get this, is that we should be able to change all these numbers, move them up or down in an organized or intellectual way, in which makes this value go to the minimum. So think of it as though it's a three-dimensional function. Okay, if it's, before we had a beta 1, beta 2, then we had a cost. Now I'm thinking back to our term in which we have y is equal to beta 1x plus beta 2. If we had that, then we could have a surface. Here's our surface, a nice surface that sat here. Think of it as you're a drop of water. You hit this particular point. You start at a particular point. You start going downhill. Eventually you're going to go downhill until you get to the lowest valley. At that lowest valley, your cost function is at the lowest, meaning you fit your data the best. It's hard to represent this with 8 different terms because I don't have 8 dimensions, but the first set with a beta 1 and beta 2 and a cost function, yeah, you do. You actually have essentially a contour map, just like you'd see a terrain map somewhere where you'd see a mountain and you'd see elevations and you might see a valley somewhere and you might see contour functions that look like this. The lowest spot would be here in this lake. So up on the hill you'd drop some water, it would basically come down and flow down to the lowest spot. So think of it as you're just water. You're going to move around in this beta 1, beta 2 area. And when you move around, what gravity's going to do is it's going to pull you downhill. As it pulls you downhill, it pulls you to the lowest valley. Now, just like nature, when it rains on a surface, it doesn't instantly go to that. It has to travel for some time. And sometimes after a rain, it could take several days for all the water to make it into this area and make a lake out of it. So with that in mind, now let's see if we can solve this. And we're going to see a problem, and I'm going to discuss what that problem is after a little bit. But let's look back at our sheet back here. You look up at this and it says starting value 1 and starting value 2. Now what he wants is he wants these as some starting values. So what I'm going to do is copy. I go over here and I'm going to paste. Come back, copy. I should have organized them differently because then I could have just copied all these values out. Paste. As you see this is going on, you can see that all of these functions change every time I paste. Watch over here. Okay, you saw that's a very big change. Copy, paste, copy, paste, copy, paste, copy, and a paste. Now you see that your first problem is this. This is the starting value that he gave me. You see a very large cost function, and you see that the functional values are nowhere close at all to that. So what seems to be the problem? And let me see if I can answer that question with a simple example. Let's put in a value here and just call it 5 minus 10. Okay, go back, put an equal sign in front of it, and what you get is a value minus 5. Let's do this. Let's hit escape, move over here, and let's put, or move right underneath it, say, put the same value, and let's square it. That makes sense. Okay, so that's 5 minus 5. Okay, you square a negative 5, you get 25. Now let's do this. Let's put a minus sign out in front of this. Hit an enter. Let's go down to here and put a minus sign out in front of that. And your first inclination is, when you look at that, it should bother you a little bit. If you're not used to programming, you don't see this. But if you're a programmer, here's what you see. Put a copy, hit an escape key, come underneath it, and we'll hit the same thing, so you see a 25 and a 25. Now let's put a 0 in front of it. That should disturb you, because what we're talking about is precedence of operators, and Excel doesn't behave in the way a programmer should. So it doesn't see this the same way that a programmer would see this. To give you a true indication of how a programmer would see this, let's change this to a programming sense. And we will keep some of this, but here's what we're going to do. I'm going to come in here and I'm going to insert a column. This column is going to be function MAC from a macro. I'm going to go in the Developer tab, go in Visual Basic, go in here, insert a module. I don't know what to call it. Function. How about just a function of macro min? And what I'm going to do is I'm going to pass in x as a double, pass in b1 as a double, b2 as a double, b3 as a double, b4 as a double, b5 as a double, b6 as a double, b7 as a double, and finally b8 as a double. Then I'm going to return a double, and there's my function. So all I'm going to do is I'm going to go over to the Excel spreadsheet or to here, and I'm going to simply extract this the way it says and put it in my macro. It's going to get mad at me, but that's okay. Oh. Okay, it doesn't like that because it wants to see the caret symbols. Then I need to go back to pick up the last term because they're double line there. He's going to be mad at me about this, so I'll do that, and he will be mad about this, but the remainder is fine. So I've passed in everything. I'm going to save the spreadsheet. Well, let's see. I want it to be an X macro enabled worksheet. Call it Gauss3. Save it. Okay, now I'm going to go back over here, and I'm going to say and MA macro min. Okay, what he wants is X first. Then I want B1, B2, B3, B4, B5, B6, B7, and B8. And then that's it. Close the bracket. And here's the thing that should disturb you. If you are used to programming and you have experience with programming, here's what should concern you. Okay, I took the word for word line out of the code and I got an answer here. I used the internal calculations of Excel and I got that. This is the actual value. In other words, here's your function, here's your data point. This is your data point. This is your function. These two numbers here and here should be the same. They are not. Here is why. And this is what should disturb you and should, if you're an engineer, keep you away from using the internal calculations in here. If I put a 0 in front of it, I basically get a different number. What it is considering at this point, it considers this. It thinks that if it looks at this, it puts a parenthesis around this. If I put a 0 in front of there, 0 minus 5 minus 10 squared, it takes the square, operates it on here if a 0 exists here. If the 0 does not exist here, it's doing this. That's not operator present. That's not the way this should work. So by leaving this on here, he's taking this and squaring it by putting a 0 in front of it. It changes this. What exists in our functions that cause this problem? Right here. Here's part of the problem, and here's part of the problem. How do you want this to occur? Do you want a minus sign and then square this? And do you want to put the bracket right here? Because now you get the same number. Now, you could claim one's error and one's not, but programming precedence considers why, think to yourself this, why in part of the package in a macro it calculates it one way, on the spreadsheet it calculates it another way. That is something to be very scared about. But let's continue and do this both ways. Now that I have this function, I can just drag it down. And if I want to change this and use this function, let's drag it down. What you'll see now is both columns appear to be the same. I can produce a macro cost equal to, and then I can do a sum here and sum this all the way to the very bottom. And what you'll see is a slight difference here. That's interesting. That's a little concerning, unless I'm skipping a term in one of these. Oh, I'm sorry. Yes, my mistake. I needed to insert a new row. Insert cost from the macro. I made a mistake. What I should have done is I should have created another term that was basically y minus the functional macro here, and then this. Did I do that correctly? Except I didn't square it. So these are the ones that should be select the entire row. Now, need to change this from E to F. So if I change this to F, should be the same. So both of these are the same now. But this portion right down here, if you want to experiment with this, it's a good idea to experiment. If you want to experiment further, here, try this. Here, let's move this one down, and let's try this. Okay, if I move this, but then if I go down here and I want to make sure that I'm squaring the right terms, you'll notice that this term ends up the same as that term. So the way Excel in the spreadsheet interprets this is different than the way the macro interprets this. But now that we say all that, the goal here is to find the minimum here. So let's go in and put in add-ins, solver add-in, up. Do it again. Add-ins, solver. We want to do the solver add-in here. So now you see under this data tab, you'll see a solver now. So you hit the solver, and what it says, this is the 2010 version, has a little bit more information in it. I want to basically, I want a target cell to be this. This is what I want to take the minimum of. I want to take the minimum by changing cells, and I want to change all those cells. And I can either hit options to take a look at my options, time, iteration, precision, tolerance, estimates, conjugate, Newton methods, hit OK, or I can change none of that and hit solve. It takes it a few seconds. Came up with an answer. What it did, and you'll have to look at this real close, it essentially changed the values that I had right here, and as a result it changed this. What it did is it took off and changed these values, looking at this one to try to find the minimum. How close did I get? Let's see. I'll just keep the solver solutions. I'll run back to the spreadsheet, or actually, never mind that. I can just go to the spreadsheet itself and go over here. These should be the answers. So let's format those cells and change them to a general, and what we see, the answer should be 98.94, pretty close. 0.001, is that correct? 100, and then 111, 100.6, 111.6, 23.29, pretty close. 73, 147, 73, 147. Now, so it apparently did solve this. The next key is, did I put my function plot in here? And the answer to that question is, no, I didn't. So what I'm going to do is I am going to create values. Say, I'm going to create my X plot and then my Y plot. So I'm just going to start with one, say 5, and then what I'll do, let's move this out of the way, is just head on down. Now what you see is I incremented up to about this value, and then what I'm going to do is I'm going to take my function here. I'll even do it this way, equal macro. Okay, now here's what I got to do. So I got to take my X value, comma, B1, B2, B3, B4, B5, B6, B7, and B8. Hit enter. So it is calling this macro every time. Move the plot over a touch, and then let's drag it down. So let's go back to the plot itself, and I'm going to put it over this location, and I'm going to say select data. I'm going to add a series. The series name function, although I'm not going to really look at putting that. I'm going to select the values I just put in, and then I'm going to select these values, which, did he already select those? Maybe, maybe not. Let me just, that doesn't seem like that's correct, so I'm going to go back. So here, and then hit OK. Now here's my other, that's my function. Here's my other thing. As you can see, my red dots. I can go ahead and say something like this. See if I can get in here and hit those. Now wait a minute, let's see. Here we go. maybe. Okay. So what I've done is, you can see the red line behind the blue dots is the actual functional representation. So that concludes this. We've actually solved this. We have discovered a problem with Excel which relates to this, and we have actually used the solver add-in to curve fit a nonlinear function, and we are done.